Hi, my name is David, and I will show you how to fit a first-order model with delay to the step response of the system. First-order step response is characterized by a slope which tends to the final value of the input times the gain of the system k. In this case, we will use u of s being the step function, so the final value of the input will be in all the examples 1. Then, um, if we have the time domain function of the system, we will see that when we reach the time theta plus tau over 3, we will reach the 28% of the final value k. And when we reach the time theta plus tau, we will reach the 63% of the final value k. Here we can appreciate a step response of a first order system. The first thing that we should do is find the final value of the output response, which in this case is 1, and we divide it by the final value of the input, which is 1. Then we locate the 28%, the 28% and the 63% of the final value, and we will found them in the times 2.3 and 3.0 seconds. So with this information, we can solve the system. But we have to remember that in this case, the step input it's not started in 0, but it is started in 1. So we have to take this in count. Also, we can appreciate here the delay of the system. It means that we have a step input and some number after we start to increase. First, we will fit a second-order system to a first-order system with delay, having g of s being the transfer function and u of s being the heaviside or the step function. We will have this graph which represents the step response of the system. And first, we have to locate the final value of the output and divide it by the final value of the input. And in this case, we have 2 over 1, which give us 2 being the gain k of the system. Then we have to locate the 28% and the 63% of the final value, and in this case we will find them in 2.04 and 3.14 seconds, and with this information we will be able to solve the system and found that theta is 0.5 and tau is 1.6. We should remember that the step input starts in 1 and not in 0. So we should add or subtract this time to the calculation. So here we have our G first order of S, the fitted system, the fitted transform function. So if we compare them, we have a very similar response to a step input. Here we have the delay, we have that the system, both the fitted and the second order real system tends to the final value, which is 2, and the system is close enough. We can use this method to a higher order system. In this case, we will use it in the transform function C of S being a third order system. First, we have to locate again the final value, which is 2, and divided by the uh, final value of the input, and we have that the gain k of the system is 2, and then locate the 28% and the 63% of the final value, which are located in 2.05 and 3.13 seconds, and we proceed to solve the system, and we have that in this case we have theta 0.5 and tau equals 1.62. So this is our fitted model, and if we compare them again, we have that the dashed blue line is our fitted model and the green line is our higher order system response. And again, it's very close to the real response, and with this we can use it to some methods or PID tuning rules or methods to control the system. Thank you.